Hi, this is Digan Sakhiwala. I will teach you maths. We will start with chapter number 1, real number, exercise number 1.4. Look at the question. Question number 1. Without actually performing the long division, state whether the following decimal expansion or a non-terminating repeating decimal expansion. So dear student, always remember that if the in the denominator is in the form of 2 raised to m into 5 raised to n, then we can say that the number is a terminating decimal expansion or it is a non-terminating decimal example. Let me take one example. Suppose we take m equals to 1 and the n equals to 1, then we get what? 10. So if the denominator in the 10 is present, then it is a terminating decimal expansion. If you take here some other example, suppose you take m equals to 2 and n equals to also 2, then you get 100. So in these all the cases when the denominator follow this thing, then we can say that it is a terminating decimal expansion. If it will not follow this thing, this number 2 raised to m into 5 raised to n, then we can say that it's a non-terminating decimal expansion. So we will check here. 13 divided by 3125. 3125, how we get? We get by 625 into 5. Okay, and 625 we get by the 5 raised to 4. So we can write here the 3125 is 5 raised to 5. Again, here 2 is not there, so instead of 2 we are writing what? 2 raised to 0, because we know that 2 raised to 0 is 1. So again, this number we can say that 3125 we can represent in the form of 2 raised to m into 5 raised to n. So we can say that this number can be represented by terminating decimal expansion. I hope you get this. Okay, we try to do other one. We have another number Arthur, that is that we have the 17 by 8. We are focusing on the denominator, that is 8. So 8 we can represent by 2 raised to 3, correct? 5 is not there because we have to represent every denominator in the form of 2 raised to m into 5 raised to n. Okay, but here the 5 is not there, so we are adding 5 raised to 0. So we can say that it is the terminating decimal expansion, correct? We are slowly moving on the other number, that is we have 64 divided by 4 5 5. The factor of 4 5 5 are 5 into 7 into 30. You can see that here the denominator not follow the 2 raised to m into 5 raised to n, not follow that. Okay, 2 is not present, 5 is not present, not follow that. So given number is non terminating repeating numbers. I hope you understand. We have the another number we have, that is 15 divided by 1600. Again, can be represent into 2 raised to m into 5 raised to n. If this 1600 has only two factor, means including so many factor 2 and 5 are there, then it is a terminating decimal expansion. So we can divide this thing into 16 into 100. We are not concerned with the numerator, so we are adding as it is. 16 we can write 2 raised to 4, and 100 we can divide into 2, that is 25 4s are 25, we can represent as 5 square, and 4 we can represent by 2 square. This 2 raised to 4 and 2 raised to 2, we know their base are same, so we can write 15 divide by 2 raised to 6, 4 plus 2 6 into 5 raised to 2. We can say that this denominator we can represent in the form of 2 raised to m into 5 raised to n, where m and n are not negative integer. So we can say that it follow it. So we can say that we can represent this number as terminating decimal expansion. I hope you get here. We are switching on the other question. Other questions are there. 29 divided by 343. Again, we will check the denominator. 343. We can represent 343 as 7 cube. Again, it will not follow the denominator, not follow 2 raised to m into 5 raised to n. It's not 1343 has not one factor 2 and 5. So it is non-terminating, repeating decimal expansion. Okay. Here we can see that 23 divided by 2 raised to 3 into 5 raised to 2. Already it is given. It follow the 2 raised to m into 5 raised to n, where m equals to 3, n equals to 2, and it is a non-negative. So it is the terminating decimal expansion. Look at here, this question, 129 divided by 2 raised to 2 into 5 raised to 7 into 7 raised to 5. Till here it is okay, 2 and 5 is present, but because of this 7, it will not follow, it will not follow denominator not follow 2 raised to m into 5 raised to n, and because of this reason it is a non-terminating repeating decimal expansion. So dear student, I think you understand, when in the denominator, if the two factors are possible including 2 and 5, then it is a terminating, and suppose one another factor is present, that is 7, then it is a non-terminating, or any other number are there other than 2 and 5, then it is a non-terminating repeating decimal expansion. Okay. We have here 6 divided by 15, 35 divided by 50, 77 divided by 210. Now you can easily give the answer. Okay, so 6 divided by 15, that is 3 into 2, that is 3 into 2, and this is the 3 into 5. So 3 is cancelled, so we can write 2 divided by 5. Here denominator follow the 2 into 2 raised to m into 5 raised to n, and because of that reason it is a terminating decimal expansion. Okay, 35 divided by 50, so we will take here 35 divided by 50. 35 we can write into 7 into 5, and 50 we can write here 10 5s are 50. These are cancelled. 7 by 10, we can also represent 7 by 10 as 2 raised to 1 and 5 raised to 1. So it follow the 2 raised to m into 5 raised to n. Denominator follow the 2 raised to m into 5 raised to n, and because of that reason it is a terminating terminating decimal expansion. "77 divided by 210." Okay, so 77 factor are 11 into 7, and this one we can write 7 3s are 21 and 21 10s are 210. Correct? 7 7 is cancelled. We can write here 11 divided by 3, 10 we are writing it 2 into 5. You can notice here 2 and 5 is only present, then it is a terminating. But 3 is also present, so it not follow the denominator, not follow the 2 raised to m into 5 raised to n, and because of that reason it is the non-terminating decimal expansion. I hope you understand. Now write down the decimal expansion of those rational number in question number 1 above which have the termination decimal expansion. Okay, so how to do that? So we have here 13 divided by 3125. So we are writing here 13 divided by 3125, that is 5 raised to 5. Correct here. Now to convert into the terminating decimal expansion, we have to multiply and divide by 2 raised to 5. So we will multiply by 2 raised to 5 and 2 raised to 5. So here we will get 13, 2 raised to 5 is 32, and here we get 5 into 2 raised to 5. So 13 into 32, we know that that is a 416, and this is 10 raised to 5. So we can write here 0.00416. I hope you understand here. So this is the way by which we can represent the terminating decimal expansion. If 5 raised to 5 are there, then we have to multiply and divide by 2 raised to 5 and 2 raised to 5. Okay. We have here other is 17 divide by 8. 8 we can write here 2 cube. Here 5 is not there, so we multiply and divide by 5 cube. So this is the 17 into 5 cube is 125, and this one is 10 cube. Correct here. We will check that what is the multiplication of 17 into 125. So here 17 multiplied by 125 equals to 2125. 2125 divide by 1000. So the answer will be 2.125. Got? This is the terminating decimal expansion. 6 divided by 15. So easy. 6, 3 into 5, 3 into 2. These are the factor of 6. 3 into 5. 3 is cancelled. We can write 2 divided by 5. So here 5 is there, we do not have 2, so we multiply and divide by 2. So decimal numerator, in that we should, numerator is anything, it is okay, but denominator is either 10, 100 or 1000, we have to convert. 5 is there, we have to convert into 10. So we multiply and divide by 2. If here the 5 square are there, then we have to multiply by what? 2 square. So here we have to convert the numerator into either 10, 100, 1000. So we multiply and divide like that. So here we get 4 divide by 10, so we get 0.4. This is the terminating decimal expansion. We have here 35 divided by 50. So we can write here 7 5s are 35, and here we are writing 10 5s are 50. Okay, so it is cancelled here. Now we can write 7 by 10 in different ways. 7, 2 into 5, 10. So easily we can write in the form of what? 0.7. This is the terminating decimal expansion. So I hope you understand. Okay, somehow we have to make the denominator either 10, 100, 1000, then it is a terminating decimal expansion. For that we have to multiply and divide with the either 2 or 5, or if any other number is present, like instead of 2 and 5, 7 and 3, like, then that is the non-terminating and repeating numbers. The following real numbers have the decimal expansion as given below. In each case, decide whether they have the rational or not. If they are rational and of the form of p by q, what can you say about the prime factors of q? Okay, so correct here. So simply thing is that we can write here 1, 2, 3, 4. Okay, so 43, 1, 2, 3, 4. Okay, so we can write here, these are the 1, 2, 3, 4. So in the denominator we can write what? 10,000 here. Okay, so you can see the denominator we can represent in the form of 2 raised to m into 5 raised to n. So we can say that here the p by q is the rational number. P by q is the rational number. P by q is the rational number, where q follow the 2 raised to m and 5 raised to n. We can represent the q in this way, 2 raised to m and 5 raised to n. So q has 2 prime factor, 2 or 5, or both 2 and 2 and 5. So it is a terminating decimal expansion. I hope you understand here. Okay, p by q is a rational number because we can represent like that, because it is we can represent the denominator in this form, 2 raised to m into 5 raised to n. So q has 2 prime factor, m and n is a non-negative number, so we can represent like that. Now we will see another example. See that this number 120, 1200, 1200. So if this number is x, 0.120, 1200, 12000, 12140, so this is not the rational number. P by q is not a rational number, because it is a non-terminating it is not terminating and non-repeating number, as well as the denominator we cannot represent in the form of 2 raised to m into 5 raised to n. Okay, it is the m and n are not negative number, so this number is, we can say that it is the irrational number. So we can say that x equals to 0.120, 1200, 12000, 1240, irrational number. Suppose we consider this number as 43.123456789. This bar indicates these numbers are repeating. So we are writing here x equals to 43.123456789. This line indicates that these numbers are repeating. Okay. Now suppose these numbers are repeating, then we can say that this is the rational number. P by q, it is a rational number. but Q is not in the form of 2 raised to m and 5 raised to n. Okay, so Q has factor other than Q has prime factor other than 2 and 5. So this is the end of today's session. Thank you so much.